All right, guys. So as I mentioned, I'm gonna have you guys watch this video of the notes, just to try to save my voice, so I can teach all five of my classes today. So I appreciate your flexibility today. The first part of the notes is something that you've already taken, so we'll go through it kind of quickly, and then the second portion is going to be new, so you'll have to write this down, and this is going to start on page 23. So when you're taking a look at rocks as a whole, and this is kind of a review of the rock cycle, remember that rocks are just a continuous process of recycling. So we're taking one rock like igneous, and then we're changing it into a different type of rock like sedimentary. And this process just goes on essentially forever, as long as we have these natural processes occurring on Earth. Now, when you look at the planet as a whole, igneous rocks are going to be the most common because our Earth is mostly molten, especially on the interior. But when you think about the Earth's surface, the most common type of rock that we find are sedimentary. And that's simply just because the process to make sedimentary rocks are going to happen only at the surface of the Earth. Now, most of the rocks that you're going to see like in your backyard or out if you're taking a hike or even just out in the back fields behind the school, most of those rocks are going to be sedimentary. So you might recognize some of the rocks that we're going to study in this unit. Okay, so now let's get into the steps of forming a sedimentary rock. So sedimentary rocks are named sedimentary because they're made of sediments. And there's three types of sediments that you can get. The first one, of course, is just plain old rock fragments. The second one, plant and animal remains. That's essentially fossil fragments. And then the last one is minerals. And usually these minerals are ones that are going to be dissolved in water. So things like rock salt and halite and things like that. Okay, so let's get into the details of how to make a sedimentary rock. So the first thing that has to happen is weathering. And weathering is the physical breaking down of a parent material, the original rock, and creating the sediments. So when you weather something, you're making the raw material for the sedimentary rock. Once the sediments are created, then they can be transported to a new location, and that process is called erosion. Once that erosion takes place, and that could be most of the time through water, but any other means as well. So it gets transported to this new location, it gets deposited or dropped, and then they pile up in layers where they get compacted and cemented together. So I'm going to show you guys a little scenario of a good place to find this. And I kind of think of this as like the East Coast of the United States. So this would be like the Appalachians. Obviously don't look exactly like that, but it's a good anagram for this. And then we have like the Atlantic Ocean would be over here. So the mountains get weathered away, usually from, wind, rain, snow, the elements beating down on it. And all those loose sediments will travel through these streams, to facilitate erosion. And then eventually, when they make their way to a body of water, that's where they get deposited. And then they're going to build up in these nice layers that you're seeing here at the bottom of the body of water. And then over time, they get compacted and cemented together. Hey, I want to talk a little bit more about those final steps. When you're actually taking the sediments and turning it into a sedimentary rock, the process is called lithification. That's sort of the fancy scientific term to turn sediments into a solid rock. And it's really made up of two steps. And the first step is compacting the sediment. So you're applying some kind of pressure. It usually is from the weight of the material over top, that squeezes it. And you can kind of see that in the picture. You're compressing it into the small amount of space as possible. So you're getting rid of a lot of the extra air pockets and things like that between the sediments. Then once it's compacted, then you would have the process of cementing to actually get those now sediments to be glued together. And essentially the way that this works is the water will get in between these little, what we call pore spaces. And remember, water is full of minerals. So those minerals that are in the water get into those pore spaces and they actually glue those pieces together and turn it into a solid sedimentary rock rather than a loose pile of sediments. Okay, so this is going to be the newer stuff. So this is where you might have to like slow down just a little bit and maybe pause the video. This is going to be the next page in your packet. Now that we know how sedimentary rocks are made, now we can get into how they're classified. Okay, and this really comes to our identification, which we're going to start on Monday when we get back from the long weekend. So the first classification group for sedimentary rock is going to be clastic. And the way that we classify sedimentary rocks is based on what they're made of, what kind of sediments they're made of, essentially. So clastic sedimentary rocks are made of clasts, or basically rock fragments that are cemented together. And you can really see that very well in these samples here. This guy over on the left is called breccia, and this one over on the right is called conglomerate. And you can really see those chunks of rock that have been glued together. Okay. And these are just the different size sediments that we can have in a clastic rock, going from the smallest to the largest. So clay is the smallest sized particle. Then we have silt, sand, and pebbles. And then you can see that the names of the rock made of those sediments is closely related to the name of the sediment itself. Okay, and then these are just some little pictures here of the different size particles. I do have them out on display in the classroom, so they're not exactly the same vials as what's up here. I took this picture a while ago, but if you want to come up and take a look at the sediments, you are welcome to. Okay, our second group is chemical, and this is very similar to one of the ways that minerals form. We talked about this a while ago. So when you have minerals that are dissolved in water, the minerals will precipitate out of the water and collect on a surface to create your minerals, or it could be the opposite, where the water evaporates and the minerals are left behind. For those of you who did the extra credit way back when and made crystals, you did this process. So some good examples are limestone, rock salt, which is halite, gypsum rock, dolostone, chert. Okay, and these sedimentary rocks do tend to look like minerals. So that's kind of how you can tell that you're looking at a chemical sedimentary rock. Okay, and then the last classification group, this is a little diagram of showing that evaporation process. And you can see your deposit of minerals there at the bottom. Okay, so our last classification group is going to be organic. Sometimes it's also called biochemical. Most people say organic, but it's there because your textbook uses that term, so I wanted you to be familiar with it. And organic sedimentary rocks come from the remains of living things, so essentially fossils. Coal is an excellent example. It's made of decayed plant material, so that's going to be organic. Another one is called fossiliferous limestone, and you can see the word fossil literally in the name there. Another really neat one, and that's what's in this picture here on the bottom right, is called coquina or beach rock. I think it kind of looks like a granola bar, but essentially it's a bunch of seashells that are glued together. And another interesting one is natural chalk. It's not the same as the chalk that I use on the chalkboard because that's manufactured, but natural chalk you can write on a chalkboard with, and you're writing with these microscopic fossilized organisms from the ocean floor. So that's kind of a neat one to sort of play around with. If you identify chalk, you can always try writing on the chalkboard with it. So these are the three groups that we use to identify our sedimentary rocks that we're going to be looking at essentially on Monday. So I'm going to jump back in here now that you're finished and explain the practice that we're going to be doing with our sedimentary rocks.